Hey everyone. So today we'll be looking at a problem from Codeforces Round. I think it was 2 days, 3 days before, around 971. And question G1, that is Yunli's Subarray queries, and this is an easy version. Specifically, we won't be focusing on the solution itself. Rather, what we will do here is we will try to figure out how to achieve that solution and how to think for that solution, as we always do here. So I will just explain this question for the people who are not aware of this. And if you have already read the question and know what the question is asking, just skip it to the part where we discuss how to reach to the solution. Or there is another part where we will be discussing a very different POV to reach towards the solution. And you can look that also. So there will be two ways of thinking for the solution to this question. You may prefer anyone. The last part is a little bit interesting. So let's start with what the question is asking. So this is a pretty simple question. What basically it's asking is you will be given an array. Okay, so you will be given an array, say 7 3 5 4 2, something like that, and your task is to make this array consecutive. Okay, to make this array form of elements that are consecutive to each other. So maybe let's just say that the new array is say 4 5 6 7 and 8. This is consecutive. It's not specific to this. You can also have like 11 12 13 14 15 in any way, right? You have to achieve this. Now, to achieve that desired array of consecutive elements, you can perform certain operations. Okay, and what those operations looks like, you can take any element from the array. Say a of I is equal to 3. Let's consider the array is 1 10 2 3 4. Okay, so here we took the 3 and we can change it to anything, any value. Okay, as you can see, the restriction here says that say index I, set b of I is equal to x, or a of I is equal to x, and where x is any integer desires. X is not limited to the interval 1 to n. That means we don't have any restriction out there for to what value we want to. We can change this to -10, we can change it to 30, we can change it to 2, anything is possible. And for each operation, okay, for each operation you will incur a cost. Okay, for 1 unit, the cost will be of 1 unit, or you can say the value of the cost is 1. And for each change, this is the cost that will bear. What you have to do is you have to the output needs to be such operations that will perform on the array such that the cost is minimum, right? We want to perform the operation on the array such that it becomes consecutive, right? And this set of operations must give us minimum cost. So this is what the question is basically asking. I will go through a case one so that we can understand it completely. Consider the first test case. Okay, sorry, this is the first one where our array is, I think, 7 5 and 3, right? This is 7 5 3. Yeah, so our array is 7 5 and 3. This is our array. I need to make it consecutive. You might say what we can do is maybe let's say change this one to 4. Let's keep it 5 and we can make it 6, right? So this is 4 5 6 and we did it in 2 operations. We can do it in 3 operations also, no issue. Let's make it 1, make it 2. Okay, let's not do this. This will anyway make it 2 operations only. Let's make it 9. The second one 10, 11. This is also one possible way, but here we did 3 changes. So this is not our desired solution. We want the one with minimum. As we can see, I think it won't be possible here to achieve a consecutive array with just one operation. So what can we do now here? How should we move forward? So first thing that should come up into our mind is that, one, obviously what the question asking is, we need to minimize our cost, right? Minimize the cost. And what this cost is dependent upon? This is dependent upon the number of changes, right? The changes that we will incur changing x to some value y. This is the cost. So obviously our answer, or the set of operations that we'll perform, will be the one where we do minimum number of changes, right? We need to do minimum number of changes, and that set of operations will be our desired answer. Now, what does it mean to have minimum number of changes? Okay, so we made it quite clear that our set of operations would be the one where we have to make minimum number of changes. But what exactly does this minimum number of changes mean, right? So first, this is the second thing that you should always try while for solving a problem, is that assume you already have the solution. Okay, you already have an abstract form of solution. If I like it, have an abstract form of solution. That means, say you already know the solution and then work with it. So let's say we already have a solution. What does it mean to have a solution? That means we already know the set of elements, right? We already know from our array. Consider we have an array of size 8. Okay, so 1 2 3 4 5 6 7 8. Okay, this is a set of arrays. Sorry, set of elements, array of elements. And we already know the values or the indices which won't require any change. Like, we can keep them as it is and they won't violate our final answer. Okay, for example, let's just pick those indices as this, and this. Okay, so these are the indices. Let's say this is our answer. This is how our answer would look. Some elements are there here, and while preparing this answer, okay, this answer, the outcome we got, and comparing it with the original array. This is input array. Okay, this is the input array. Same 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. Same 8 elements. These elements of these indices, we didn't change them. Okay, so these are the elements we didn't change, and this is the set of operations where we didn't make we made maximum number of no changes. Okay, or let's say minimum number of changes. And let's say this is what our final output configuration looks like, or not output, let's just say this is the desirables configuration. This will be the set of consecutive array where we will have, and this is the best one. Okay, this trying to convert the input array to this form will give us the, which will require us the less number of changes. Okay, and let's assume that these are the indices where we didn't make any change, right? So if these are the indices where we didn't make any change, how would they look like, right? Let's just say this one, the starting one is x. Okay, of course, as this is the part of the answer, we will have x plus 1 here, consecutive, right? We'll have x plus 2 here. Let me just one thing, write these as red. This will be x plus 1, x plus 2, x plus 3, x plus 4, x plus 5. Let's make it x minus 1, and this will be x plus 3, and this will be x plus 6, right? So as you can see, this will be x, this will be x plus 2, this will be x plus 3, this will be x plus 6, right? And these are the indices. Let's just say I will name them 1 based index. Okay, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. Okay, now we have formulated our abstract idea. We have a solid foundation out here. Now we need to make some certain observations. Precaution here, some people would be able to already see the observation, but I would still give you a different way to think of it so that you can still capture the essence of it, because maybe there would be a scenario where you might not be able to immediately capture the observation. Okay, so let's first discuss the obvious one here, or maybe okay, let's just discuss the obvious one here. So let's focus on this one, right? The difference here, difference of this value, right, the element and the index here is x minus 2, right? I mean, let me just erase this one. This is just our input array. So let's focus on this one. Okay, so here the difference between the element and its index is x minus 2, right? Let's focus on this one again. Now the difference between its element and index, that is x plus 2 minus 4, again is x minus 2. X plus 3 minus 5 is x minus 2. X plus 6 minus 8 is again x minus 2, right? So as you can clearly see here, this is x minus 2, this is x minus 2, this is x minus 2, this is x minus 2. All of these special red colored elements, right, and their indexes, difference between, have constant differences. Now I will give you a proof regarding why these values, these random values, can't have the same difference, right? I will give you the proof later, but for now just accept that these differences are unique to these special marked red elements. Okay, so we just noticed that these red indices elements will have constant same difference throughout. Basically we can see they belong to the same group of difference, that is x minus 2. And what did we talk about this x, I mean sorry, these red values? These are the elements or indices, let's say indices, where we didn't change anything, right? We didn't change anything. These red indices were the elements from our original array where we didn't make any difference, sorry, any changes. Or base, and what did we claim there? We claimed that this will be, our answer will have such red values in maximum number. So we want to make an operation out there where we have such such red indices in maximum amount. Now it's quite obvious, as you can see. Maybe let's just say there was some other configuration. Okay, maybe say this one, right? This one and this one belong to a group of another same differences, right? Say maybe x minus, not saying x would be the right answer here, but let's just say they belong to the group of, say, difference 5. Maybe this one and this one belong to a group of difference 6. So we will have different groups, right? Let's call it differences of group. Okay, maybe certain set of elements will have difference 5, certain set of elements will have difference 2, certain set of elements will have difference 3, right? Or certain set of elements will have difference x minus 2. For example, in this case, the set of elements that have difference x minus 2 between the elements and indices is 1, 2, 3, and 4, right? So 4, maybe 2 here, 1 here, 1 here, right? And what did we say while formulating our uh, approach? We said that if I'm considering this array as my solution and it has x numbers of indices, special indices, right? Special indices that belong to the same group of differences, I want this group to have maximum size. So obviously I will pick this group to be the one whose elements won't be changed. Won't be changed. Why? Because obviously this group has maximum number of elements and I won't have to change them, right? And I think from now on the solution is pretty obvious. You just need to create certain groups, maybe let's say A, B, C, D, where we will have certain set of elements which will have difference between a of I and I, right? You store them and pick the maximum one, right? You pick the maximum one, and your answer would simply be size of the array minus the maximum one you get. This will be the solution, obviously. Now let's just come to the step where we'll figure out how to think of it in a very different way. Now, this is not yet the second type of solution. I'm just going to explain how you can reach to the same observation in another way. Maybe this was too not so straightforward to come up directly. So, what do I mean by simplification? Let's start from the step which is common in this part and that way of thinking. Is that obviously we have our answer array. Okay, this is our answer arrays. Let's say 1, 2, 3, 4, 5. And let's say these are the indices where we won't have to make any change. Let's keep it this one. Okay, these are indices, and let's give them name. Okay, let's call it 10, 11, 20, 13, and 16. These are the index value. This is 1, this is 2, this is 3, this is 4, this is 5. Okay, so what I'm saying is, okay, so this value here is the first one of our solution, right? Let's, for simplification, I only have to make it consecutive, right? Let's just make them, turn them into 1, 2, 3, 4, 5, 6, 7, 8, like that. Okay, and it won't affect uh, our solution. Why? Because see, what I will be doing is, let's say it is starting from here. Okay, this is the first element of our set of indices that won't require any change, and let this is the first element of our set of indices that won't be changed. Okay, and let this be the first element of it, and this is the index of it. What I'm saying is, match it with this index value. Why? Simplification. As I said, if you what actually I'm trying to do is, let's say these are our indices 1, 2, 3, 4, 5, 6, and these are the values of those indices which won't be changed. I'm just saying convert them to those index values itself, like make it 2, make it 3, make it 5, so that our final solution will itself look like 1, 2, 3, 4, 5, 6 set of indices. Okay, if you didn't get it, I'll repeat again. What I'm saying is, for the sake of simplification, we don't have to do big, large numbers, and maybe it will be easier for us to, it looks nice if you have 1, 2, 3, 4, 5 above and 1, 2, 3, 4, 5 in the indices. If the indexes are 1, 2, 3, 4, 5, 6, and if we are saying in our solution index 2, index 3, and index 5 won't be changed, then what I'm saying is, in your input array, make such changes, we'll come to that, such changes such that this value, and this value match their indexes. That means make it 2, make it 3, and make it 5, and that will be possible. As I said, if these are consecutives, right? If this is 2, this is 3, this is 5, it will always be possible to make them to these index values. What we can do is, that's pretty simple. Find, you can find any element of the set of indices. Let's say, for example, let me put the value 15 here. Let's put 15 here. Enter. Let's put 15 here. Oh my god, 15. Let's put 2 here, 3, and this will be 13. This will be 12, and let's make it 0. Okay, I want, you can pick any element. I will just, for the sake of simplicity, pick this 12. I want to make this 12 to 2. What should I do? I should just subtract 10 from here, right? And I will subtract 10 from everywhere so that I preserve this order, right? Minus 10, minus 10, minus 10, and minus 10. And this will become minus 10, comma 2, comma 3, comma minus 7, comma 5, comma minus 8. And the indexes will be 1, 2, 3, 4, 5, 6. Why did I do this drama, right? It seems more complicated. Why? Because now the observation that we made earlier would be pretty much obvious out here. As you can see here, we can clearly see these were our special indices, right? These are the values that won't change while our solution is formed, right? And we can clearly see the difference here is 0, the difference here is 0, and the difference here is 0. This will give you some hint. This will give you that hint that wait a minute. So if I'm saying that these are the indices that won't change out there, then maybe this collectively will have same difference between the indices, right? That is quite possible, and this will help you gather that observation that we made earlier. Now, while formulating or while coding, we don't have to necessarily do this step or minus 10. This was purely for the sake of making that observation that they will be having same differences. Now coming for a proof. Now we'll just for the sake of our own satisfaction, we'll also prove that what if maybe someone would say that, okay, what if this will also become zero? Then I can't clearly say this is the part. This is I can clearly say this isn't the part of this set of special indices, right? So let's prove that this won't be possible. That obviously only the consecutive section, like this special indices which are already in consecutive form, like 2, 3, then here something, then 5, will have the same differences, and the other indices which are not the part of it won't have the same differences. Okay, let's come to the proof. So now let's look at the proof. Basically, the difference between I and j indices is alpha. X is a part of those special set of elements out there that won't be changed, and we're saying y is not the part. Basically, when we say y is not the part, what we are saying is, if I want, y can't be a consecutive. Now I'm using consecutive in a wrong sense, but basically, if I will fill these positions with plus one, and then plus one, like x plus 1, x plus 2, x plus 3, and this will become then say dot dot dot. There was difference as the indices difference alpha. Y won't be equal to x plus alpha, right? So basically, our claim is, I'll write it here, x plus alpha not equal to y, right? This is what it will basically mean, that y is not part of the special set of indices, and x is a part of the special set of indices. Now, if x is a part of special set of indices, then we will have x minus I say is equal to k. It belongs to the group of k differences. Okay. Similarly, y minus j, we are claiming that could also become to the k, right? While even though this is not a consecutive section of the series that x will follow, we are still saying that it might have the same difference, and that's why our approach might be wrong. As both are key, let's equate them. That will become x minus I is equal to y minus j, right? What I will do now is, I will send this j here, and I'll send this x in this side. So this will become j minus I is equal to y minus x. Now we know from this the difference between I and j is alpha. So this will again become y minus x is equal to alpha, right? I can write this again as y is equal to alpha plus x, which is a contradiction, right? We just contradicted ourselves. As you can see, we said y won't be equal to x plus alpha, but we just proved that y is equal to alpha plus x. So if y minus j, its index is equal to k, it will automatically become the part of those set of indices. It can never happen where it won't be a valid part of set of indices but still have the same differences. So our approach is completely fine. So basically what we have to do is we have to prepare certain groups A, B, C, D, and store the elements or indices, whatever you want. Say those who have a count of elements, those who have same differences of A between them and their indices in B and in C and in D, and pick the one whichever is maximum. How to do it? I won't be saying it because a hint would be we need certain kind of data structure which can store these indices. I mean, if you're solving this level of problem, I think you will already be aware of those data structures. But still saying, we need certain kind of data structure that can do this for us in maybe order of 1 or maybe log n. I don't know. Think about it. Okay. And then the final solution, if you're going for log n, will become n log n. How? Figure this out yourself. Now, let's look at a very different kind of POV where this is an interesting one. Okay, I won't say very much interesting, but this is still an interesting way to look out for the solution. You can also arrive to the solution in two ways. I will give you the two ways. I will give you the most easiest one to understand, but still feels like a bit tough, but still it is quite easy. So basically, what is the question asking us, right? The question is asking us, if we have an input array, say these are our elements, we needed to find out a set of elements, right? We needed to find out set of elements that will be consecutive part of a consecutive sequence, right? Say these are our special indices that will be part of our consecutive sequences. If you have x here, and let's say this index is I, so of course, with one increase in index I plus 1, this x should become x plus 1, ideally, in our ideal solution. With another one increase in this index I, that is I plus 2 plus 1 plus 1, this x should increase another one in it and become x plus 2. In I plus 3, this should become x plus 3. So basically, for 1 unit increase in I, we want 1 unit increase in x, right? For sake of interest, let's just say, uh, let's call our elements as y, and let's call this will be our elements, and let's call our index is x, right? So if I want you to, if I want you, and if I tell you, hey, for each increase in x, for each 1 unit increase, right? For each 1 unit increase in x, I want 1 unit increase in y. How would the equation look like? Won't it look like y is equal to x, right? Of course, this is what our equation will look like, because if our equation is y is equal to x, if you make x change to x plus 1, y will become x plus 1, say, I mean x1, let's say x1 is equal to x plus 1, and y1 will become x1. This means y1 is equal to x plus 1, and x is equal to y from here. So y1 is equal to y plus 1. So as we can see, if we made x increase by 1, our y is also increasing by 1. So of course, this will be the relation between index and element. Y is equal to x. Does this look familiar? This is more of an inspirational way of thinking, how we can say y is equal to x. If we draw a graph for y is equal to x, how does it look like, right? Y is equal to x as a coordinate. How would it look like? Like how the equation in the coordinate geometry looks like y is equal to x. Let's see. Y is equal to x looks like in graph or coordinate geometry. Okay, pardon me. This isn't how graph should look like. Okay, this is y, this is x, and this is y equal to x. Right? So, okay, that's nice, but how does it help us? Just for the sake of our interest, or I mean for the sake of creativity, let's just plot our array elements, uh, where x is the index, as I mentioned, x is equal to index, and y is the element. Okay, we'll plot it. Let's put some random values out here. See, this is 1 point, this is 1 point, this is 1 point, this is 1 point, this is 1 point. Of course, they won't be coinciding. This is here, this is here, this is here, another value here, maybe another value here. Okay, so for certain index, for example, let's say this one here is for index 1 2 3, so 3, we have 1 2 2. Basically what this means is we have an array, okay, and in our array this is 1 2 3, in third position we have element 2, so I took 3 here, 2 here, and plotted it. This is what it will look like. Now what we said was the relationship between our index and the element will be y is equal to x, right? As earlier mentioned, y is equal to x, because 1 unit increase in x will result in 1 unit increase in y, and this is what the line would look like. Something, okay, try something like this, right? Okay, let's make it fast through this also. And this is what our y is equal to x look like. And we can clearly see the points that will lie in this line would be the points, or with the indexes. Let's say this is an index, this is an index, right? This is, let's say, I, this is j. These indexes and the elements will satisfy this y is equal to x condition, because for this value, if I'll increase x with 1 unit, y will also increase with 1 unit. But is this the solution? Is this our final solution? If you clearly see, I mean look clearly, let me try this so that it's obvious. If I take again another line that passes through this, okay, and it is quite parallel to this one, okay, this will still have equation as y is equal to x plus c1. C1 is some constant, this is c1, because as you can see here, then you will ask, okay, wait, if I'm increasing x with 1 unit, is y still increasing with 1 unit? Let's check it. So let's say now our x1 is equal to x plus 1, right? So what would y1 become? Y1 will become x1 plus c1, right? Y1 would become x1 plus c1. Let's substitute in place of x1 x plus 1. So this will become y1 is equal to x plus 1 plus c1. And from here we already know that x plus c1 is equal to y. So y1 would become y plus 1. So obviously for this case also, as x increases with 1 unit, our y also increases with 1 unit. So this is also a valid line equation of line, you can say. And if you are already aware of family of lines, you would know that for the same slope we can have different set of lines, family of lines out here that will have same increase rate of increase, differentiated, and you will get the same rate of increase for y is equal to x, or y is equal to x plus c1, x plus c2, etc. So all of this y is equal to x plus c1, x plus c2, x plus 3c, c3, they will have, for some constants c1, c2, c3, will have same 1 unit increase in index for same 1 unit increase in index, they will have same 1 unit increase in the value of the element. So how do we use this? So basically, from this we can say that some set of elements will fall in some family of lines, right? Maybe you have, here we have two elements, right? So two elements fall in y is equal to x member of the family of straight line. Here we have three elements. Three elements fall in the equation of y is equal to x plus c1. Maybe here if I draw another one passing through here for c2, one element falls in y is equal to x plus c2 family. And from here, as you can see, this is the family of line which captures most number of elements. So this will be, we need to look out for a set of elements and indices that satisfy this line of equation, right? Y is equal to x plus c1. And how do we get that? Well, we can definitely do y minus x is equal to c1. So we will find set of elements and subtracting the indexes that have c1 as the difference. Similarly, we will have y minus x is equal to c2, y minus x is equal to c3, etc, etc. Some set of elements that will satisfy, that will come in the group of c1, come in the group of c2, come in the group of c3. As earlier in our first approach, we have again, we'll again find the member of the family of straight line that covers most number of points in it. So this was another way of thinking towards it. I know it looks a bit complicated, but actually this is also quite obvious if you will think in the direction, because as 1 unit increase in index makes 1 unit increase in element value, it becomes quite obvious. In fact, if you notice here, this question isn't just limited to linear increase. We are having a linear increase out here. We can have any kind of increase, even exponential. Say for example, maybe the question would be, just remove all of it. Say maybe the question asks you that for, like, maybe the question would become, instead of asking you to find consecutive minimum number of operations to make the array consecutive, it might ask you minimum number of operations so that you can make the array arithmetic progression with, say, 2 units, right? A plus 2, a plus 4, a plus 6, right? Why? How would this look like? This is index 2, this is index 3, this is index 4, this is index 4. Okay, how would this look like? For 1 unit increase in our index, we are having 2 unit increase in our element value, right? For another 1 unit, another 2 unit. So this equation would look like y is equal to 2x plus some c1, right? As we can see, let's make x1 is equal to x plus 1. So y1 would become 2x1 plus c1. Substitute this value here, so it will become 2x plus 1 plus c1. This becomes 2x plus c1 plus 2 y1. This whole value is y, so y1 will become y plus 2. So question, it can be anything, not necessarily restricted to linear increase. You could have exponential, arithmetic, any function of x. Honestly, like, it could be, we can have any function of x, as in, like, for each unit increase in index value, we could have any kind of exponential increase. We logarithmic, I'm not sure logarithmic, but yeah, you got the gist. So basically, what was the main gist of this problem was, so basically what was the main gist of this problem was, the things we encountered was, first, abstract solution based approach, right? You assume your solution form, you formulate how your solution would look like, and then backtrack from here. You take out certain information that you can get. If this is my solution, what are the certain informations I can have, right? You can start from having a solution, assume that you have a solution. And second would be simplification. Again, if you were able to get that observation immediately, that was nice. But as you can see, as you might have noticed, the moment we made like, the elements match their indexes, right? What we did was, maybe we had 1 for 0, 2 for 2, 3 for 3, 4 for something like minus 10, and for 5 we had 5. We were able to see that this will be matching, or even if you didn't see the difference, you would have noticed that the consecutive values would be same as their index, and the difference would be 0. This was quite easier to make that observation as compared to if it was in this form, right? Say 10 increase, so this will be 10 at index 1, 12 at index 2, 14 at index 3, 0 at index 4, 15 at index 5. So quite tough. if you are not paying attention to make that same observation in this case as compared to this case. This is basically, if you are not aware, what we are doing is we are setting the coordinate to our, or you can say standardizing, a form of standardizing. But if you have a coordinate and these are the points, if these are the points, we are picking a one point, let's say this point, we are shifting it this distance and this distance, so that this becomes the origin now, and every other point is around it, something like this. This will not, it will become this kind of standardization. I think standardization, yes, standardization is correct. So this is what kind of standardization that we're doing. But the gist is this: abstract solution, start from backwards simplification, and that's it. This is how this is solved. Bye bye.